what is a redox reaction? But from 10th standard you would have learned what is a redox reaction and all, so I'm not digging again back to history and geography if you have it. So the question is, Mrudula, is this a redox reaction?
Yes,
Why?
because oxygen is getting added and subtracted.
I don't
Like
want you to
removed.
give this conventional explanation for redox. Gone are the time that we have to talk with respect to the conventional description of redox. We have to express it in terms of electrons. Okay, so take this word, reduction and oxidation occurring simultaneously in a reaction is called as redox. In 10th standard you should have learnt about addition of hydrogen is called reduction, addition of oxygen is called oxidation. Those are very conventional module of understanding it. So let me take that Fe3 plus is here, which is getting added with an electron. What is the charge of ion right now? Fe2 plus.
Yes, ma'am.
Fe2 plus is here. It is becoming Fe3 plus. Here I am writing electron in the left hand side. In the previous category I wrote the electron on the right hand side. What does this say? 3 plus is taking minus 1. 3 minus 1 is plus 2. That's what we have written here. 2 plus has become 3 plus. So I have 3 E minus 1. 3 minus 1 is only 2. Right? So we are going to describe it with respect to electrons here. Here you can see addition of electron has happened with the reactant. Always your redox reaction is expressed in terms of with respect to reactants only. What has happened to the reactant? The reactant attracted an electron. In other words, the reactant gained electron. Gaining of electron is called as reduction. The way to remember it is GER. Gain, electron, reduction. Look at the second category. What did the reactant do? It lost an electron. Loss of electron is called as oxidation. LEO. Loss, electron, oxidation. What you are seeing right now is a separate off cells. There is one individual cell, there is another individual cell. When this reaction is happening together, where in same plot, both oxidation and reduction is going to happen, I call such reaction as redox reactions. Let us assume SN2 plus Fe3 plus is becoming Fe2 plus SN4 plus. Let us consider this equation. Look at tin. Tin from 2 plus went to 4 plus state. Tin from 2 plus went to tin 4 plus state. 2 is becoming 4. That means when I subtract 2 from it only, I will get this 2. So I write plus 2 electron. Is it a loss of electron?
Yes, ma'am.
So this is nothing but oxidation reaction. Look at ferric here. Ferric to ferrous. Fe3 plus became Fe2 plus. That means this 3 has taken up an electron to become 2, isn't it? So this
Yes, ma'am.
is reduction. I can see oxidation and reduction are happening simultaneously in a reaction. Okay, so such reaction is called as redox reactions. Clear?
Yes, ma'am.
Now ma'am, the next question comes over here that you said tin 2 plus is giving 2 electron. But this Fe3 plus is only taking 1 electron to become Fe2 plus in the reduction reaction. How do I compensate this electron here? This redox reaction itself is called as mutual reaction. That means if someone is giving certain quantity, the other one should take it. If someone is demanding certain quantity, the other one should give it. This is quite mutual here. So I understand here tin 2 plus is giving tin 4 plus by losing this 2 electron. Fe3 plus is taking up this electron to become Fe2 plus. I can see the number of electrons are not the same. In other words, 1 mole of this Fe3 plus needs 1 mole of this electron to become Fe2 plus. At how much tin is providing you? 2 electrons. So I understand 1 mole of Fe3 plus needs 1 electron. If I give 2 electron, how many moles of ferric should have reacted? 2 moles of ferric. So what will you do? Just multiply it by 2. So now I write 2 Fe3 plus 2 electron is becoming 2 Fe2 plus. Now we are going to write the net reaction for it. What is the net reaction? By cancelling out the same terms in the opposite side and by summing up the same terms in the same side. I can see 2 electron is in opposite side. So I cancelled it. I am checking, is there anything common terms here? No. So let me sum up the left hand side here. Tin 2 plus 2 Fe3 plus is becoming tin 4 plus 2 moles of Fe2 plus. This is your balanced ionic equation. Okay?
Yes, ma'am.
Right. Now the question is, what is the N factor here? What is the N factor? N factor is nothing but the number of transferred electrons. It is called as N factor. How many electrons did you transfer here? 2 electrons. So the N factor is 2. Clear, ma?
Yes, ma'am.
Right. So, basically we don't see this ionic equations at all. All you see is molecular equation. Whenever you see a reaction, you can see molecular reactions are there. Then what is the difference between ionic reaction or ionic equation with respect to molecular equations? Nitish, are they started redox or they completed it?
Didn't even start.
Didn't even start. Okay. So what is this molecular equation? Consider I am giving KMnO4 plus some S2 minus is reacting. H2C2O4 is reacting to form CO2 to form like this a reaction is given. Here you can't see any ions here. I can see the molecular form only. In order to do this balancing reaction, we generally prefer writing the ionic form. Potassium permanganate. This compound is called as potassium permanganate. This can be written as MnO4 minus. Now what do you mean by that? The ions like potassium, sodium, chloride, sulfate, all these things are called as spectator ions. Just like a spectator, you go and watch a cricket match in a stadium, you don't go and play there actually. You are a spectator here just to cheer them up. Similarly, in order to support the charge of permanganate ion, potassium was there. In other words, spectator ions are those one whose oxidation state do not change. If their oxidation state do not change, I call them as spectator ion. That means K plus will remain as K plus also in my product side. It will be available in the solution. It will not involve in any kind of reaction at all. any kind of redox reaction, to be very careful. Okay, so I write KMnO4 as MnO4 minus, because K is plus 1, then permanganate should be minus 1 na. Similarly here, what you are seeing here is oxalic acid. Hydrogen is right now in plus 1 oxidation form. It will not lead to any change here, so I did a C2O4 2 minus, because H2 is there, so 2 minus to form CO2 plus manganese oxide here. This is minus 2, manganese is plus 2, so I did as Mn plus 2. This reaction is called as ionic form of this equation. Okay, ma?
Yes, ma'am.
Right. So we generally do any kind of this redox reactions only in ionic form, not in your molecular form. It's very difficult for us to balance it. Let us see what are the types of redox reactions we have.
Ma'am,
Tell me, pa.
what will happen to the spectator?
They will remain in the solution itself. They will be forming some salts. Here the redox reaction is only concerned about those ions which are getting involved in their change in oxidation states.
Okay, ma'am.
Okay, yes. Tanuja, is this a redox reaction?
Yes, ma'am.
Why?
Both oxidation and reduction takes place.
Where is it taking? Can you identify where is the oxidation and where is reduction?
Ma'am, no, it is a disproportionation reaction. Here, displacement reaction takes place.
Is it disproportionation reaction or displacement reaction?
Displacement reaction.
So it is not a redox reaction.
No, ma'am.
Alright. She is right. Let us first understand about finding out the oxidation forms. Oxidation states, okay? So I am providing you K2Cr2O7. I want you to calculate the oxidation state of chromium here. Nitish, what is the oxidation state of chromium here? You learned to calculate the oxidation states in your 10th standard foundation?
No, ma'am.
Okay, no problem. We will have set of rules for calculating the oxidation states. Whenever you are having native elements, that means the element is all alone. It does not have any compound formation here. Consider your periodic table. You see 118 elements are written here. Have they written any charge on it?
No, ma'am.
No. That means they are native there. Okay. So even in a reaction, native elements could be formed. There is every possibility that it get formed. For let example, I say zinc plus copper sulfate is becoming zinc sulfate plus copper. Here you can see native state of the element is there. In that cases, their oxidation state is 0. Let's describe what is this oxidation state. The tendency of an element to either donate the electron or to gain the electron in order to attain the noble gas configuration is called as oxidation forms. I repeat, the tendency of the element to provide the electron or to gain the electron in order to attain the stability or in order to form a compound is called as oxidation states. Okay, so when I have a native element, the state is 0. Second, if I am having homonuclear elements, molecules, homonuclear molecule like hydrogen, fluorine, chlorine, etc. Here, 2 hydrogens are bonded, 2 fluorine is bonded, 2 chlorine is bonded. The bond has happened between the same element itself. If both the elements are same, where is the necessity to give the electron or take the electron? Do you understand what I say? There is no one to pull it,
Yes,
or
ma'am.
no one to give it. It is equal among them. So in such cases also, the oxidation states here remain 0. For example, they are saying zinc plus NaOH is giving you Na2ZnO2 plus hydrogen. Here the hydrogen gas with the oxidation state of 0 here. Now the third case. Whenever you are having the chance for it to show its oxidation stability, that is what is called as oxidation state. I am talking about group 1. Group 1 elements. Lithium, sodium, potassium, rubidium, cesium. I am missing out francium because it is radioactive. Just leave it. So lithium, what is the electronic configuration? 1s2. Yes, come on. 1s2, 2s?
1.
1, that's right, because lithium is atomic number 3. Now this lithium can very happily release this electron, so that you say lithium becomes lithium plus plus electron. It lost one electron very easily, right? So generally group 1 elements always takes plus 1 oxidation state only. They will not show any other oxidation state. Other than if they are native metals, they will show. If not any compound that you say, they will be with plus 1 oxidation state only. Similarly, let's take group 2. Beryllium, magnesium, calcium, strontium, barium. Beryllium is the atomic number of 4. It is 1s2, 2s2. Beryllium can easily donate this 2 electrons. So, all this group element can show plus 2 only. You never see them showing plus 1 oxidation state. Instead, they give plus 2. The next thing is group 3b. 3a, boron family. Boron, aluminium, gallium, indium, thallium. Boron is with atomic number of 5. 1s2, 2s2, 2p1. Here you can see in the valence shell, how many electrons are there? 3 electrons are there. So basically boron family shows plus 3. Usually they show plus 3. But thallium, we will do this when we do periodic properties still more further, but as of now you just remember that thallium very stable configuration is with plus 1. Other than that they all show plus 3. The next one is group 4a, carbon family. Carbon, silicon, germanium, tin and lead. The configuration of carbon is 1s2, 2s2, 2p2. The valence shell is showing how many electrons? 4 electrons. So carbon family preferentially shows us plus 4. From here you have an ambiguity. As it can give 4 electrons, similarly it can take 4 electrons also, isn't it? To attain stability.
Yes, ma'am.
So carbon shows from plus 4 to minus 4. Any state it will show. Here preferentially lead shows plus 2 state. You can see in boron and carbon family, the last element, see here it is 2s2, 2p1 I told you. I said only plus 1 is exhibited. That means this electron from s orbital is not participating in the reaction, in bond formation. How many electrons are there in this? Yes, 2. 2 means pair, right? It is not responding, so I called as inert. Inert pair effect. The 2 electron that was present in yes is inert towards the bond formation, and I call this effect as inert pair effect. The next group is group 5a, nitrogen family. Nitrogen, phosphorus, arsenic, bismuth. Antimony, bismuth. Here nitrogen is with the configuration 1s2, 2s2, 2p3. You can see the valence is having 5 electrons here. So the very general oxidation form for them is plus 5. minus 3 to plus 5 they can show. They can show minus 3 to plus 5. Ma'am, why is this minus 3? How many electron it is having already? 5 electron. If it takes 3 more electron, it will attain its octet configuration, 8 electron. So it is minus 3. What about bismuth? Bismuth will also not use this 2 electron, isn't it? So bismuth shows preferentially plus 3. And this effect is again called as inert pair effect. Is that clear till this?
Yes, ma'am.
Yes? Okay.
Yes, ma'am.
We'll wind our session with this. We'll continue with the redox reactions. Do your test properly. Though we have only completed one of the chapter, atomic structure, and in mole concept. What about mole concept? Whatever you have learned is enough for you to attend the exam in our class?
Yes, ma'am.
Okay, then do it well. Bye, da.
Thank you, ma'am.
Thank you, ma'am.
இந்த ட்ரெஸ்ஸு
இன்னும் கட் பண்ணல காலை. சொல்லுங்க.
இந்த ட்ரெஸ் டிக்கி கொஞ்சம் தூக்கலாக இருக்குது.
ஆமாம், என்ன இந்த ஒரே ஒரு பையன் மட்டும்தான் பேசுகிறான், நம்ம ஒன்றும் பேசவே மாட்டேங்கிறீங்க.
ஒரு பொண்ணு ஸ்ரீதரோட பொண்ணு பேசினா கொஸ்டின் கேட்டுருன்னு போயிட்டா இருக்கும்.
இன்னும் அந்த பையன் மட்டும் அது தவிர எதுவுமே பேச மாட்டான்.
வேற என்ன பேசணும் அவன்?
அவத்தாரணியா வேணா பேசுறேன். எஸ் மேம், எஸ் மேம், நைஸ் மேம். ஒரு பையன் எத்தனை பசங்க இருக்காங்க உங்க கிளாஸ்ல?
2 பேர் தான் இருக்காங்க.
அப்படியா? தனுஜா நீங்க?
அது இன்னைக்கு சும்மா வந்து அட்டன் பண்ணுறது.
டெமோ கிளாஸா?
நீட்டுக்காக தனியாக கிளாஸ் எடுக்க சொல்லிச்சு. தனியாலாம் எடுக்க முடியாது, நீ வேணும்னா வந்து இங்கே அட்டன் படிக்கமா எங்க கூடியன்னு சொல்லிட்டேன்.